Good evening, everyone. So today, in continuation of my last video of abstraction, this is the second video of this design principle section where I need to discuss modularity. Though I have already discussed coupling and cohesion in some other video, earlier video. That's why I may not focus much about coupling and cohesion. I will share the link in my YouTube video so that if you really want to understand the coupling and cohesion, you should go and visit that video again. But here I will talk about just lots of things in modularity concept. It is just a theoretical concept, like conceptual division of your overall system, how you are going to divide it, how conceptually you are dividing your system so that managing of those systems are easy. Like just for an example, and most of us are programmer only. So in programming, when we are dealing with a large problem, like divide and conquer concept, right? If you remember, divide and conquer, what we are doing, we have a large problem. Now, since I could not able to solve that large problem very efficiently, so we deciding there that divide that problem into a sub problems, a smaller problems, and when it is easy to manage that problem, we are solving that problem, right? And then again going back, we are just integrating our solution in such a way that it produces the final solution as a original problem solution, right? So this is same thing in this part also, modularity in design term also. Like in modularity, what we are doing that as a complete system, if we need to expand or scale for large, resource, large kind of computation, large requirement of memory, large requirement of storage, right? If we try to scale for the complete system, it is very difficult because the dependency and interlinking between the code is so high that you cannot scale something, one part of the code in some particular area, right? That is the really drawback of a large system if it is not divided into the component or modular form. That's why for every architect, software architect, it is the primary responsibility to divide the system into components. And once they decide this component, then scaling is primarily dependent on now the component. So if component is following, coupling and cohesion as per the standard, like less or low coupling and high cohesion, if they are following it, probably then there is no problem in scaling this component as per the system requirement. And there, if you remember, if you have experience in like microservices or monolithic architecture in earlier days, you quickly identified this problem. Like in component section, there are two different kind of component we are dividing. Some component are considered as a common component, which is a kind of utility component which serve across the system. For example, if you talk about the security, logging, or anything like which is required for every component, then those components can be separate out, and this component is considered as a utility component. Rest all component have either zero dependency to other component or minimum to minimum dependency. As much as less possible, you have to put, ideal condition is zero dependency of this component, one component to another component. And for coupling and cohesion, as I already told you that we have already created video earlier, and there I have explained you lots of things about the coupling and cohesion. One example, if I have to tell you that modularity, which is the real world example, look at the car, right? If you see the car have different components. Car has wheels, car has engine, car has a steering, car has seats, car has body, right? So all these are components which come together and build and produce a complete product which is called car, right? The same way in system design also, our job is to divide big system into a small system or subsystem which can be mapped or considered as a component, and those components are primarily divided in such a way that they have less coupling with others component, and within the component we have high cohesion, high integrity, so that it would consider as a single unit to serve something, right, for some purpose. So mostly this is theory, and because it depends on a structure, so I'm just wrapping it because it is a quick discussion and it's not require much effort for programmer. But yes, this is to produce the bigger and best, to produce the better structure of your code so that it will serve your purpose in terms of scaling, extension in future times, or maybe many people of you who are experienced, they can easily identify that how much effort is going at commercialization stage, when in the late stage you are getting some bugs and that bugs has lot many dependency on different component. So those are the painful times you can avoid if you in earlier stage, if you can design your system well structured, less coupled with among the component, and highest cohesion within the component. If you design it properly, then definitely you have a very limited scope. Whenever bugs will comes, it has an impact, its impact area is very less, and so it is easy to manage, right? It is those kind of codes are easy to maintain, easy to extend, easy to scale for as per your system requirement, and so on and so forth. So this is the benefit of this modularity approach. I hope you will find interesting this concept, and although it is theory, but it's a very helpful concept to create the good structure. So I will give you some code also later time when I build some bigger requirement, and I will try to divide that requirement into a separate component form, and you will easily understand how this kind of structure is helpful for you. For now, I'm wrapping this video here only. Thank you. Thanks for listening, and have a nice day. Have a good, day is already over now. So let's say have a nice good night, and keep learning, keep moving, keep progressing. Thank you. Thanks a lot.